Hi and Assalamualaikum. My name is Aida Nazira binti Mahadi and my matrix number is 2022-74398. So now I will explain the introduction. What is Newton's law? Newton's law of motion are three basic laws of classical mechanics that describe how the motion of an object is affected by the force acting on it. This law can be summarized as follows: Newton's first law, Newton's second law, and Newton's third law. Isaac Newton first introduced these three laws in his book, which is Mathematical Principles of Natural Philosophy, published in 1687. Newton used this law to study and explain the movement of various physical objects and systems, which formed the basis of classical mechanics.
So my name is Auni Izzati binti Muhammad Razaki. My matrix number is 2022-66562. So we want to talk about the Newton's second law.
So what is Newton's second law? Newton's second law is a quantitative of the change the force can produce on the motion of the body. It can be stated as the rate of change of momentum of a body is directly proportional to the resultant force on it and is in the same direction as the resultant force. Newton's second law is one of the most important in all of physics. So basically, Newton's second law of force applies to an object that rests force equal accelerate in the direction of the force.
So we can conclude that when we have a small force, it's given the small distance. When we have a more force, it's given the more distance.
Next, the advantage of Newton's second law. Firstly, understanding motion and force. It helps us comparing the relationship between an object's motion and the force acting upon it. Second, accurate calculations. It allows us to accurately calculate the force of motion related to specification. Last but not least, practical application. It enhances our understanding of how Newton's law applies to real-life situations.
Question 1. Sally challenges you to a race. On the first day, you run off the course and your car strikes a large bale of hay. Your car still produces 5,000 Newton of force, but now it accelerates at only 2 meters per second squared. So what is the mass of your car now that the bale of hay is tied to it? So from the question, we got information which is F equal to 5,000 Newton and A equal to 2 meters per second squared. So we need to find a mass. We use the formula M equal to F over A, where 5,000 over 2 and equal to 2,500 kilograms.
For question 2a, if Lisa pushed 5 kg of the empty shopping cart with the force 100 Newton, find the acceleration. For question 2b, if Lisa wants to push 14 kg of the full shopping cart like how she pushed the empty shopping cart, how much force is needed to accelerate the full shopping cart? Assume the acceleration for the shopping cart is 5 meters per second squared. So, the answer for question 2a, we use the formula force equal to mass times acceleration. Since we have to find the acceleration, then the acceleration is equal to force over mass. In the question, given force equal to 100 Newton and mass equal to 5 kg. So, we can calculate 100 Newton divided by 5 kg equal to 20 meters per second squared. Therefore, the acceleration for the empty shopping cart is 20 meters per second squared. Next, the answer for question 2b. Since we have to find the force, so we use the formula force equal to mass times acceleration. given mass equal to 14 kg and the acceleration is 5 meter per second square. So, we can calculate and get the final answer, which is force equal to 200 Newton.
Lastly, the conclusion for this video is Newton found that the net force is equal to the object's mass multiplied by the change in of velocity over time, often known as the acceleration formula. Newton's second law states that the net force acting on an item is proportional to its acceleration. A basic understanding of Newton's law is necessary for everyone to comprehend the motion that occurs in everyday life.